Part 2 of the GSB-201 grounded grid linear, and this one's a little bit longer, so settle in. We're not only going to cover some of the schematics and mods I did, but also we're going to try a GRC9, an Angry 9, as an AM exciter into the linear. And we're going to go over a little bit of Gonset history. This is Part 2, GSB-201 Linear. And when I key the 520, it's in the proper ALC and current range and output power range. Everything's fine with the exciter. Let's turn the amplifier on. Okay, the step start just went in. Now, in the tune mode, with the exciter, let's put some power into this thing and let's look for our dip. Okay, we're resonant. Now we're going to go to full CW output power. So I have to put it in the Vox position. And we want it right around where it is, about 260 to almost 300 milliamps. Still have a good dip. Yeah, that's fine. Now we're going to go to the operate mode. And we're going to load until we get up to around 600 milliamps. Just about perfect. At this point, we're going to engage the RF detector. Bring it up to half scale. Again, you're at full power now, so don't go key down too long. Both the exciter and the power amplifier at full power. Now, all we're going to do at this point is we're going to touch that loading control and peak that output meter. That's it. See how we peak that? Just a little further to the right. That's it. The amplifier is now ready for single sideband service in its most linear fashion. And it's putting out about 600 watts.
So when you're hooked up to an amplifier, there's two ways to reduce your output power. One way is to, load the amplifier lighter. Simply have the dip on the final deep. The other way is to reduce your drive into the amplifier. Now with a 811A grounded grid amplifier, or really any grounded grid type amplifier, you want to do it with excitation power. You don't want to do it with the amplifier loading. You want to really completely drive the amplifier and load it very heavily, and then back off on your excitation to get the output you want. This reduces grid current. It's easier on the tubes. It improves the linearity. It allows you to drive with less power. So load the amplifier fully with adequate drive and then lower your power by backing off on the drive. That's the way to do it. Now for single sideband, you saw how we really loaded the amplifier heavily. If you're just doing CW, okay, straight CW, you don't need to do that final step of peaking the output with the RF detector meter. You can just do it the old-fashioned way with tuning and dipping the plate and looking at your power meter. And if you're doing AM, and a lot of people do use AM, they'll have a low power exciter. Maybe it's a DX40, perhaps it's a low power solid state transmitter, it's a transceiver running AM, and maybe it's only putting out 20 or 30 watts. It could be a military radio like a GRC9 that's only putting out 15 or 20 watts of AM, and you want to bring that up to something like a 100-watt carrier. Well, the linear amplifier does make sense. It'll give you that 100-watt carrier and you feel like you've got a decent AM signal. So the way you do that is you do the heavy loading with CW, just like we did setting it up for single sideband, heavy loading, but then reduce the drive to around 275 milliamps, 250, 275 milliamps, and that will give you that 100-watt carrier, and you won't be overdriving the amplifier. The tubes will be happy, and so on. So no problem doing AM with a linear.
This is the GRC9, affectionately known as the Angry 9 backpack transceiver. Transmitter receiver, really, not a transceiver. The bottom portion is the receiver, the top is the transmitter. Capable of about 20 to 25 watts on CW. This was developed at the end of World War II, at least a simplified version of it was, and by the time the Korean War came about, this was a very useful radio in hilly country of Korea. Now, by the time of Vietnam, the U.S. had pretty much permanently switched over to FM, wideband FM gear, and these sets were still being used by some armies in the 50s and 60s, including the French army, who left a whole bunch of them in Vietnam, and thus the North Vietnamese Viet Cong used the Angry 9, the French version of the Angry 9, against the U.S. Very successfully. So this radio has been in pretty constant use, probably up through, the end of the Vietnam War. Okay, let's look at the GRC9's output. This is the low power mode, 1, 2, 3, 4. This is WU2D, about 12 watts out. Okay, we're hooked up to the amplifier now. We're going to put the meter into the high power mode so we can 1, 2, 3, 4, 5. This is WU2D. WU2D on the GRC9. About 110 watts output. 1, 2, 3, 4, 5. Testing 1, 2, 3. Looks like we're just under 200 milliamps, well within the range of AM linear operation with the GSB201. So we have increased our output power from 12 watts to 100 watts using the linear. Okay, we'll let it warm up a little bit. This is WU2D on the GRC9/RT77A. I'm using the Gonset GSB201 Linear, and this is giving about 10 dB of gain with the linear. And the resting current on the linear is down around almost 200 milliamps. So you like to keep it below 260 milliamps when you're doing linear amplification with AM. Anyway, I'll say 73s to the whole net. And everything seems to be okay here. Over to Dale, KW1I from WU2D. Go ahead, Dale.
Mike, very easy copy, and we heard the station from Gardner, Mass. come in, not real strong, and so we'll keep it very short.
First, a little bit of Gonset history. The initial founder, Robert Roman Gonset, and that's Gonset with 2 T's, was born in 1891 in the Ukraine. He emigrated to Canada and finally moved his family to from Alberta to California in 1916. The older Gonset established the Gonset Company in Burbank, California to manufacture electronic equipment. This did not include amateur gear. The Gonsets had one son, Faust Gonset. Faust Robert Gonset. He was a rabid ham, but he was sure to keep his business well separated from his ham radio hobby. In the 1930s, Faust contributed articles about transmitter modifications to Radio Magazine. In 1942, he co-edited the Radio Handbook, also known as the West Coast Handbook, for many years, and the major competition to the ARRL Handbook. This book is really central to the West Coast amateur scene. The ham radio part of Gonset and the plethora of Gonset ham and civil defense equipment that we all know, mobile gear and so on, really did not get going until the late 40s and early 50s. Faust continued the ham business until it was sold off to L.A. Young Spring and Wire Corporation in 1958, located in Burbank, California, one of Gonset's original suppliers. So the GSB 100 and 200 series of amplifiers were basically all built in Burbank, California. Faust stayed on during the transition period, which lasted a few years. But after the sale, the Gonset Company began a steady decline through the mid and later 60s. Product quality went down and the number of new products dropped. Later, the company was sold to Amico. Amico, remember the Amico products? These were part of the Aerotron company located in North Carolina, and they made aircraft radios. With each successive merger and sale, the company grew smaller and eventually disappeared. So basically by 1963, both Faust Gonset and Leo Meyerson, both radio giants in their own right, one Gonset, one Globe, had sold off their namesake companies, and they formed new companies that debuted HF single sideband transceivers. Gonset had left behind the company bearing his name, minus the final T, and he started a company called Sideband Engineers, SBE-33, SBE-34, and so on. And Meyerson formed Galaxy, the Galaxy 3, the Galaxy 5, and all those famous sideband transceivers. It begins with the Collins 30L1 Linear, 4 811As, and they're resting comfortably horizontal position in this amplifier. About $520 in 1960. Most of the other amplifiers cost between $300 and $400. And in the Collins circuit, they did add the input networks, which are very helpful today for solid state radios. And this allows you to have a more linear waveform and improves the shape of the grid current into the 811. So having some type of a pi or L network on the input of the 811A grounded grid system is quite an upgrade. So this is a good feature of the 30L1. The Hammond HL500 was a kit. Popular for a little while. This is like a $250 or $300 type kit. And it's a very simple 811A amplifier. I like the metering. You have your separate grid current meter, your plate voltage, your relative power output, and they put the plate current meter right in the center tap ground where it should be. The only real mistake I see is they have L3, the choke, in the high voltage lead. This should be located about here. The Warrior amp, the HA10, this is the amplifier that my Elmer ran with a Heath Marauder and a Mohawk receiver. Beautiful amplifier. It's using the 866 rectifiers. They didn't go for solid state on this. They must have had a bunch of these to use up. They could have gone solid state. They have the choke properly in the center tap ground lead. And they're doing the metering properly in the ground lead as well. Like the look of this amplifier, it does of course lack the input tuned circuits. Separate power and high voltage switch. This is a little bit easier on the tubes. You can light them up, then you can apply the high voltage. It's not a true soft start, but it certainly is an improvement over one big old thumping switch. The resting bias, they're taking off a 10 volt output on the main transformer, and puts the amplifiers in grounded grid linear. Nice little amplifier. Relative power output over here, and it even has an RF monitor output for your scope. So this is a very clever amplifier, the Heath kit. Of course, people did solid state the power supply. They did put a Zener diode in the right in the grid circuit in order to do a kind of self-bias, safety bias on the tubes. And this guy did a soft key. So he's actually soft keying just the high voltage, which is interesting. He's not soft keying the entire thing with the filaments. He's just soft keying the high voltage, and that's how he keys it. Very clever. Now with the 201, it's also a very, very simple amplifier, but they did decide to use solid state rectifiers. It looks like a nice setup. With something like this, they're depending on the 6.3 volts not only to light the tubes, but they're stealing some bias off it, the operating bias. Well, if you have a 60 hertz transformer hooked right up to the input, it basically is impressing hum on the signal. It's like you're modulating it at 60 hertz. So this is a no-no. They should have used a center tap transformer winding here. Also, they're depending on full cutoff bias to be supplied externally from a power supply. So you'll see that I brought that on board. It takes a full 117 volts AC to actuate the TR relay. Neutralization comes back to a winding on one side of the bifilar winding. And hey, by the way, these grounded grid amplifiers do require neutralization. They can take off and oscillate into a giant power oscillator and blow up just like any other amplifier can. So they do require neutralization. My modifications to the Gonset GSB-201 involved bringing it kind of up to code as far as safety goes, putting a real 3-wire cord on there, and instead of having the fuses in the actual plug, putting real fuse holders on the back of the transmitter. They have an excellent filter system here for RFI protection, a dual pi filter, balanced. I inserted the step start here in the circuit with a 10 ohm 10 watt resistor that it shorts out. My step start is kind of primitive. It's just basically a 10K resistor across a 4700 capacitor that turns on a MOSFET that draws the relay in. The problem with a soft start system like this is once it's keyed, the capacitor remains charged, so if you turn the amplifier off and then back on within a couple of minutes, it turns on almost immediately. You lose your accuracy, in other words. It'd be better if you had a monostable multivibrator like a 555 controlling the timing. But it does work, and it makes sure that everything comes up soft. Now, the tune operate switch, you can see it's just shorting out a big 4000 ohm resistor, and this is what allows you to do tune in a very safe manner. This particular power supply, I kind of like it because it stacks 100 microfarad caps with balancing resistors. I increase these to 150 microfarad caps, and it gives you a little bit more capacitance. So, rather intelligent design in this amplifier in that they put the choke that does the filtering for the power supply right in the ground lead of the bridge. So that's a safe place to put the choke. Now, high voltage is not on the choke like if you inserted the choke here in the high voltage lead. That choke could short to its case. So they smartly put the choke in the negative lead if you want, or the ground lead. They're also doing the metering in the ground rather than trying to insert a meter in series with the high voltage lead. So a lot of really smart engineering just in the power supply here. Now, one thing that I did was I established an artificial center tap. I am lighting up the tubes with the 6.3 volt part of the transformer, just like before, but I'm not grounding one side of it. Instead, I'm using a small, it's like a 3 amp 24 volt transformer, and I'm just putting that transformer across the secondary to establish a center tap. You could also do this with a pair of low value resistors. Anyway, this was a quick and dirty way that I learned from WA1HLR Tim, and I installed this inside the cabinet. Also, rather than relying on the 6.3 volts to establish a operating bias, I have a separate transformer. It's one of those 120 volt AC, 6.3 volt AC transformers that were so popular in the old days, and I use half of it as the protection cutoff bias and half of it as the operation bias. So there's a clever way, and of course another transformer that we've added. I had to put in a transformer to make the 25 volts DC.
Okay, here's the AGC port that I've added. Don't you hate people that modify old equipment? Anyway, this BNC connector is added. There will be some mini coax going back to the ALC feedback, and that'll be completely shielded going back there. And this is a safe way to get the ALC out of the linear amplifier for feedback into the transceiver.
And you can see that I've added the ALC output right from the negative power detection system already existing. This diode you might want to replace with a shock key so you can get enough voltage out to go back to your transceiver. But mine seemed to work okay. The ALC needed to be level shifted a little bit, but I was getting up to around -7 volts at the ALC output. Anyway, those are basically my modifications to the original GSB-201 Linear.
I got lazy, and all I did was I took a ferrite, wrapped a few turns around it, put that ferrite right on the coax line, and then used a small capacitor to make sure there were no harmonics that were coming in. I didn't take time to resonate it or go crazy like that. All I wanted to do is when I put the thing in CW to see a nice sine wave, and it's a nice sine wave. Now when we're looking at envelopes, and this is the tune position, so I'm not hurting the transmitter or anything, you typically are going to be, having a waveform like this because you need to see the envelope. So when we're testing sideband, it's always good to have a scope handy and a pickup method. 1, 2, 3, 4. Okay, so we want to change the time base till we see something. Hello, hello, 1, 2, 1, 2, 1, 2, hello. And then you want to put the thing in a trigger mode. 1, 2, 3, check, 5, 5. And this is just a good way to evaluate the single sideband signal that's coming in that you're going to amplify with the linear. The TS520 transceiver has automatic level control built in. It also has an external provision to bring automatic level control in and basically mix it with the onboard ALC. The lower negative voltage dominates. Testing 1, 2, 3, 4, 5. Testing 1, 2, 3, 4, 5. You can see it's staying in the ALC on the front of the transceiver. We have a good pattern and we can see the power going up. Okay, so it's doing what it's supposed to do. The image on the scope is what we would expect. Hello, check, 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 check. 1, 2, 1, 2. And now we can turn the linear on and you'll be able to evaluate the linear and see if you get a lot of flat topping, you just get a bigger signal, that kind of thing. Now I have modified the amplifier so that it has an automatic level control feedback signal now. That is a negative voltage that goes into the transceiver, and we'll be setting that up. Okay, I hope you can see this meter. I'll try to get it pointed a little bit better. Basically we have the watt meter. I'm in the tune position and I have this little device plugged into the octal accessory socket, remote socket in the back. And when we go into tune, you can see we're putting out about 20 watts. I'm in the low scale on the meter, about 20 watts. Now this 9-volt battery down here is hooked up reverse, so it puts a negative voltage using the potentiometer. So we're going to put a negative voltage into the ALC, and we're going to watch and see what happens to the power as I put more and more negative into the ALC. As you can see, I brought it down to 2 watts quite easily just by putting some negative voltage on there. I can bring it all the way down to 0 and all the way back up to 20 watts. So that's how ALC works. That little device isn't used for ALC, it's used for QRP contesting with these old hybrid rigs. Basically you put that little device on the back of your hybrid and you can run QRP with your transceiver. It's a little trick that's been around for about 30 years and a very simple thing to build. All it takes is a potentiometer, 100K pot, a 9-volt battery, and a fancy knob on the front. That's what it requires. And of course the octal plug to be able to plug into the back of the transceiver. But there's a little 10-minute project that gives you QRP with your hybrid rig. I'm sure that this little negative feedback variable system that we plugged into the accessory socket to lower the power would work just as well on many modern radios. Many modern solid-state radios also have an ALC input, and this allows them to be lowered in power. So try this on some of your older radios that have an ALC input, and it's a way to get QRP in a safe manner. So there is a whole lot of mythology swirling around about ALC, whether it's good or bad, especially with single sideband. Now we have a way of getting the ALC signal out of the linear amplifier, and we know that the 520 will accept ALC. Let's see what we can do in the next video, the final video on the GSB201.